Hello everyone, welcome to DevCon 2015 and I hope you're having a great experience so far. In this session we're going to cover how Bluetooth Smart is enabling things in the IoT. A little background about myself, my name is Ash Patel and I'm the Regional Marketing Manager for Renesas' Medical segment and Bluetooth Connectivity Solutions. I have a Master's in Electrical Engineering and MBA in Marketing, and I've been in the industry for 18 years, mainly on the analog mixed signal side. I started off designing first 10 years and then moved to marketing. Some of the companies I worked in the past, TI, InvenSense, Freescale, and Maxim. So as you can see, a lot of analog mixed signal background now clubbed with the MCU portfolio. This is one of our themes for Renesas ecosystem. Now, as you can see, Renesas is not only a device company, we got devices, platforms, and solutions, and it is an ever-growing ecosystem to enable our end customers. Theme for DevCon 2015, it's accelerate, innovate, and differentiate. So for this particular session, the challenge I picked was IoT is an evolving field, and people in multiple industries are trying to figure out how they can get their products connected to the IoT. So not only figuring out which protocol to use, and once they figure out which protocol to use, how do they implement and quickly put that connectivity standard into their product? That's the challenge. And I think the solution for this particular case, not for every particular product, but by bulk of the volume is Bluetooth, especially for the WPAN space. So in this session, we're going to learn why Bluetooth Smart is the leading connectivity standard for IoT devices. We'll go over just some basics of Bluetooth technology, how it has evolved in the last 20 years. And then I'll give you an overview of Renesas' integrated MCU plus BLE solution and how easily you can incorporate that into your product. Agenda for today's session, IoT definition and market size. Role of Bluetooth in the IoT. We'll cover the difference between Bluetooth Classic and Bluetooth Low Energy. How do you select a Bluetooth solution? Once you've decided that you want to use Bluetooth for your product, how are you going to go figure out which particular solution to take and what all it comes with to make the decision making easier? Go over the RL78 G1D, which is our first Bluetooth device. It's an intelligent wireless MCU plus BLE device. Summary and close with question and answers. And if you have any questions in the middle, feel free to stop me. I'll do my best to answer. Let's start with the definition and market size for IoT. So there's so many definitions floating out IoT. There was one nice little summary I found in an IHS report, and I'm going to use that one here, not going to create our own definition. So first, the distinction between IoT and IoE. So there are IP addressable devices and connectable electronic devices. They club together to form the IoT. If you add to that electronic devices which are not connectable, like your calculator or the traditional watches, plus unconnectable objects like furniture or chairs and something like that, then you get the IoE. That's what is referred to as the Internet of Everything. Now, delving a little further on the IoT side, what is IoT? IoT is enabling a mechanism to get devices connected and bring out the embedded intelligence amongst devices. It's not only connecting machine to machine. It could be object to people, people to machine, machine to objects, any of that combination. And we can divide that Internet of Things in 5 major blocks. First one are the devices, the sensors, or anything which is giving some useful information. The second is the collection of the data through some connectivity standard. Then you access the data on the cloud, which can be the third block, and then you can run analytics on the data which is available in the cloud, which is also referred to as big data. So that's the fourth block. I think we are somewhere in that region today, and what needs to happen in the future is need to extract some nice unique value out of the data we have collected from all these devices, which can help improve life or quality of life and add some benefits to the society. To summarize what IoT can do for you, this is a very nice statement out there. Basically, IoT can be used to provide unique value proposition and create complex information systems which are greater than the sum of the individual components. Now, everybody says IoT, and as I said, it's an evolving field. So it may be a buzzword. Some people think, is it real? So let's look at some market size and data numbers to back up the growth and the demand in the future what IoT will create. This chart here shows the IoT connectable devices by market segment. So in 2015, there were around 36 billion units which were installed and they can be connected to the IoT. And from 2014 to 2019, the size is going to go from 31 billion units to 62 billion units. So you're going to see it doubling up in the number of connectable devices in the IoT. They are dominated by the industrial and consumer segment. What's going to be shipped in the future? So this chart shows IoT connectable devices which will be shipped in the future. So in 2015, 9 billion devices were shipped, and again, they're going to grow, not double, but they're going to go from 7.8 to 12.2 billion in the 5 years. And they are again dominated by industrial and consumer electronics. So a lot of the shipments which are going in the future and they are connectable to the IoT are dominated by industrial and consumer electronics. And these are big numbers. Of course, everybody will have their own theory behind it, but they're still pretty large numbers. Now, there are various standards available to get your device connected to the IoT. So why Bluetooth? What role does Bluetooth play in the IoT? There are a variety of reasons, but this slide summarizes what are the major reasons why, why Bluetooth is dominating and will dominate in this space. Number one, Bluetooth is ubiquitous, it's very robust, low power, and it's easy to work with. Number two, smartphones and tablets, they all come with Bluetooth, and they are sort of the gateway or your control device for most of the applications today. So that naturally makes it Bluetooth like the preferred connectivity standard, at least on the wireless side. Number three, Bluetooth SIG has done a great job over the last 20 years to keep evolving and adding features as they see the market evolving. And some features like Smart Mesh, IPv6, extended range, they're only going to open up new markets for Bluetooth to go into newer spaces, which is just going to add on and take some of the other competitors out of the race. Looking at the market size, the same data, but segmented by connectivity standard. So here, as you can see, in the 5 years, 2014 to 19, the number of Bluetooth devices going into the number of Bluetooth devices which will be installed and can be connected to the IoT are doubling up, or more than double, from 8.4 to 17. And 28% of them in 2019 are Bluetooth enabled. The rest is wired and other wireless. So clearly one technology is going to dominate compared to any other technologies out there. And you've got so many in the wired and the wireless space. As far as shipments go, similar story. From Bluetooth-enabled devices will double up in the 5 years, and 35% of them, which are shipped in 2019, are Bluetooth-enabled. So that's a large number for one technology to be covering that particular segment. Now this chart is low. I put it all on one slide because it has a story, and I have a handout there because it's maybe difficult to read. The concept here was for each segment, what's displayed is the preferred connectivity standards. And on each of the charts, I mentioned the key point or a preferred feature which makes Bluetooth suitable for that market segment. The first chart, and the legends, by the way, are not the same for each chart, so please look at the colors differently, otherwise it's very confusing. So for the first one, it's the smart home devices where mesh is preferred, and Thread and other protocols had their space in there. But Bluetooth, the next end of Bluetooth, is going to come up with mesh as part of the standard, so which should make it very preferred for smart home automation. And you already see that with the Apple Smart Home Kit and the development going on in that direction. Then you got the sports and fitness. So BLE was designed not being backward compatible with classic Bluetooth for a reason. The profiles and everything was designed keeping this market segment in view. So it has a clear advantage in this market segment. There were other standards like ANT Plus and those. They're not to be found anymore. They're almost gone. Health and wellness, where security is important. So as we progress, Bluetooth SIG has done a great job of adding security features, privacy, security, encryption, step by step. They've kept increasing the security of the BLE protocol. so which makes it suitable for the health health and wellness market. Consumer electronics. I don't think there's any other protocol with this type of capability which you can install, which you can put in for this cost, the cost which BLE comes with. So it really makes it preferred for the consumer electronics market. For retail and commercial devices, beacon. With low power, the beacon is going to enable the whole retail industry, which again, Bluetooth has a great advantage there. Industrial electronics. Now, this is the next version again. It's not today, but the range is preferred, and Bluetooth SIG for the next version is working on a low data range, extended range, feature for BLE. So that should make it, again, get into the industrial electronics space. You got computing devices, which basically you don't know what you're going to connect to your computing devices, and Bluetooth becomes like a hub for connectivity for your peripherals or sensors or data. So that gives it an advantage. It will always be there. Then you got the mobile devices where they act like a gateway, and sensors, watches are connected to mobile devices, which again makes Bluetooth very preferable there. In the automotive world, you still got the classic Bluetooth, which lets you do audio, video, headset stuff, peripherals, data commands, and it's versatile for the automotive world too. So again, you always find Bluetooth in the cars nowadays. So if we add this all up, I think Bluetooth is the clear winner by volume for the connectivity space. Let's look at how Bluetooth has evolved in the 20 years. The diagram here shows which particular version of Bluetooth you should be using or is being used as per the particular application or a product. So if it's a headset where you audio or video streaming going on, it's Bluetooth Classic. If it's the newer kind of monitors, activity monitors or fitness monitors, which come on for X amount of time and then sleep for a long amount of time, and are portable applications, they are the Bluetooth Smart. And cell phones or PCs, they use the Bluetooth Smart Ready because you don't know what you're going to connect to. So the earlier standards, version 1.x, 2.x, and 3.x, are referred to as the Bluetooth Classic, also legacy. And they were made popular by audio streaming and command streaming for cell phones and headsets. That's how they got started. And they went all the way up to 3 Mbps base data rate. And all of them use the 2.4 GHz GFSK modulation schemes. Then a few years ago, Bluetooth Smart, which is also referred to as 4.x, or Bluetooth Low Energy was adopted. It's not backward compatible. It was designed not to stream data, but to communicate state or control information. And that was the whole, and power was the main factor considered when designing this particular protocol. And the speed, the physical speed it works at today is 1 Mbps per second. Also referred to as BLE, Bluetooth BLE. Then you got the Bluetooth Smart Ready. That's part of the 4.x standard too, and it's also referred to as dual mode. Basically, it supports BLE and the Classic. So that's how Bluetooth has evolved. They used to go with version numbers. Now they go with the marketing terms. They don't want us to use BLE or anything. They want you to use the marketing terms. Sorry, what, repeat the question.
The legacy is faster than the newer version. Do you know why?
So I'll repeat the question. The question is, why is the legacy version faster than the new BLE version of Bluetooth, right? So it's just the design. It was designed for a different reason, right? So as I said, it's not for data streaming. It was designed for low power and passing on control or state information, not for continuous data streaming. So that was the whole motivation to change the architecture. And going forward, they are going to bring up the speed because the technology improves with the same power, you can bring up the speed. So they're going to go back up and bring the speed up. But that's why it's not backward compatible too. It was the whole different, they wanted to enable a whole different thing. And that's why you still have dual mode available. Picturesque view of Bluetooth applications. If you're using the classic Bluetooth, these are the applications you will see it around. Headphones or media player, speaker where there's audio, video streaming going on. For all the newer kind of applications, healthcare, fitness, beacons, industrial or peripherals, Bluetooth Smart is the one used. And for hubs or PCs, laptops, or TVs, you will see the Bluetooth Smart Ready being used. So it's just a slide which gives you a quick grasp of what particular Bluetooth standard is used in which application. Okay, so after 4.x came out, how BLE has progressed. And they've done a lot of nice little small steps to make it more favorable for different markets or particular application. So in 4.1, this was the add-on features after the 4.0. I'm not going to cover all of them, but there are a couple of ones worth mentioning. So coexistence with wireless signaling, like LTE or other GSM or something, that was improved. So in your cell phones especially, the robustness of BLE connections were improved a lot. Then another one worth mentioning is dual mode. So in the BLE, you couldn't do master-slave on the same device. This particular thing lets you do that. You can do master and slave on the same device. 4.2, they added the IPv6 profile, also called the ISP Internet Service IPSP profile. So now you can connect to the internet and you can get an IP address on a BLE device. Of course, it goes through a gateway today because the routers are not there, but still, you can connect to the internet and you get an IP address. So this profile was adapted in 4.2. And another thing was secure connections. So while pairing is going on, they improved the encryption, which is FIPS compliant, and take a case study of a smart home or a smart lock, right? So while you're pairing, you don't want somebody to be sniffing your security code. So they added that feature. Now it makes it more suitable for smart home applications. I'll give you a little time, just leave it if you want to read the other ones there. Next generation, which is going to be adopted mid-2016, also going to be called 5.0, and we are allowed to disclose some information, not all of it because it's not out public. These are the key features which are going to be added on in the next generation. Mesh, which will make it very suitable for automation, building office automation. Long range, so they're going to have a mode most probably where the data rate goes down, but the range will increase.
What range? Range, you said range will increase.
Range will increase. To what range was the question?
Yes.
I'm not sure yet because the spec's not released.
On the mesh side, is it just sleeping endpoints, or can routers sleep too in the spec?
So right now there's a working group
Yeah.
that is working on the mesh. So it's really in the early draft forms. And also
Yeah.
we cannot disclose right now because we have confidentiality with the same. But just so that you guys know, mesh is coming.
Yeah, the details just can't be disclosed to everyone publicly, and they have not finalized them. So, but the message is that these are the incremental changes coming. And the higher speed, the speed's going to go up to 2 Mbps for the 5 layer, and so you're going to have higher speed on the next generation. And they're also looking at directional connection. So for the last one, pretty interesting, if you take a case where you're in a casino somewhere and you have a player card with yourself, which is Bluetooth enabled, if you walk to machines, they don't know which one to talk to because there are multiple machines and multiple players, right? But if it's directional finding, then you're going to be near that machine and it knows which player card to talk to. So that's the angle from where they're thinking. So as you can see, they're slowly adding things so you can enable different applications, different markets. Now, Bluetooth Classic versus Bluetooth Low Energy, right? The Bluetooth Classic was designed as a scatternet topology. So you could have you had one master and up to 7 slaves formed a piconet, and then multiple piconets. Somebody could be a slave in a different piconet, and they formed a scatternet. The architecture, how Bluetooth Smart is designed, is completely different. It's a star bus topology, and it's an ad hoc network. It's a one-to-one connection. So there was a major overhaul. Really, the whole architecture was changed. On the right side, I got various technical specs and comparison between Classic and Bluetooth Low Energy. We covered a lot of them. I'll just go over a couple of them. So in the Classic one, you could only do 7 slaves. Now you can do unlimited. It's just hardware limited. It's not limited by the standard. Security was improved in the newer generation. Robustness also was improved. The AFH, the frequency hopping, was made smarter. So in your house, especially with Wi-Fi, it's more smarter. It won't drop connections. And another key thing for this fitness or activity monitor, so this portable devices, is the latency, because it comes on and off, right? So you don't want to be taking 100 milliseconds on battery. So that really reduced a lot. So you can make it come on and off on a portable device and not consume that much power. How does a Bluetooth stack look like? Here I've shown a dual mode architecture and a single mode architecture. Basically, it has 3 layers. A link layer, which is your physical layer, and then you got your host layer where the smartness for the protocol is, and then you write your profiles and apps. So 3 basic layers. The difference between the classic profiles were written on the L2 cap layer, and that box shows you the classic profiles, basic and extended data rate. The new profiles are written on the GET profile. That enables you to write custom profiles. So now you're not dependent on the SIG. You can just do whatever you want, as long as the data packets fit your needs. So that's the major difference between the two architectures. Here, I've shown the adopted profiles for the classic and the new ones. And the main reason to do that was to just show how the theme has changed. On the left side, you got the object push or file transfer or audio or video streaming type of classic profiles. On the right side, you got all this heart rate and blood pressure, which is the health and fitness or snapshot type of information coming out. So that was the change between the two standards. Okay, let's take the example of one profile, the simplest one, Find Me profile, right? What does profile mean for BLEs? So Find Me profile defines a behavior where you press a button on one device and some other device will give some alert signal, voice, audio, light, or whatever it is. The way it's architected, and how all the profiles are architected like that, they have 2 rows. In this case, there's a Find Me locator and a Find Me target. Those are the name of the rows. And from the technical point of view, one of them is a GET client and another one is a GET server. Server is where the services run, and the client is the one where it just gets the data from the server. That's how all the profiles are organized in Bluetooth, BLE. If you break your profile down, so when you get to actually using the BLE and try to figure out the profiles and stuff, this is how a profile looks like. Profile consists of various services, and a service consists of characteristics, and various characteristics. It could be one or many. And a characteristics has value, properties, and descriptor. So that's the basic architecture for a profile. And Bluetooth has already defined the units, the format types, and declarations, and some of the descriptions for you. But you can custom write characteristics, services, and profiles if it's not adopted by Bluetooth. So it's a lot of flexibility for you, and it's very simple to implement. So the basis for all Bluetooth profiles is the attribute. And that was the layer you saw on the stack a couple of slides ago here. So attribute protocol right there, and you got the generic attribute profile. Those are the 2 blocks, right? Those are the basis for all LE profiles. So the at block is nothing but the attributes. What an attribute is, it comprises of 3 elements. It's got a 16-bit handle, a UUID, and if the UUID is adopted by Bluetooth SIG, it can be 16 or 32-bit. If you write your custom, it has to be 128-bit. And then you got a value of a certain length. What the GET does, the next layer, is it combines all this bunch of attributes and groups them into some meaningful services for you. And on top of that, you write the profiles. Okay, so we went over the IoT and how Bluetooth is enabling the IoT and then the background of Bluetooth. Let's look, now let's say you decided you want to put Bluetooth into your product and you want to figure out which solution to use or which IC or which module to use, right? So factors you should consider. 1, do you want to go with a module or do you want to go with a IC? It's a cost analysis basically. If you are above a certain volume, you're going to go with the IC and do the RF design and do the certification, which is not cheap. But if you don't want to deal with all that, you can go with a module, which will be fully certified. You just plug it down. The area is not that much more, and it's ready to go. Hardware support. So,
And it has a built-in antenna.
Yes, I got a further slide on that. The hardware support, from the hardware support point of view, right? Along with the IC, what is the company going to provide you? Do they have the EV kits, a solution kit, a PC GUI for evaluation? Do they have apps to show certain particular modes and stuff like that? So that's the things you should be looking for. From the software point of view, what IDE is supported? What are sample programs are available? And is custom profile API available? So those are a few of the software-related stuff to look for before you pick your solution. From the IC itself, from the hardware point of view, these are some of the key features which come into play when making a decision. Power efficiency for all portable applications. So what are the power modes? What are the sleep currents? Then MCU horsepower. What type of MCU processing power do you need? So you pick accordingly. Because most of the BLE devices are integrated now. It's not only a radio, it's mostly always a MCU plus a radio. And then you've got memory choice, how much memory you need, RAM, flash, and data flash. Size of the package and number of IOs. Last but not least, you should also look for the roadmap for the company so you don't get stuck once you've done all the work to do your software development and then you have to go to a different platform. And quality and reliability of procurement from the company. Okay, RS78 G1D. So this is our first Bluetooth product right now. It's an intelligent wireless BLE MCU. I'll cover some features and support structure around it. There are a lot of Bluetooth devices in the market. What's the differentiation for this particular device? So these are the three main highlights. One, low power consumption. So which equates to long battery life, right? Which everybody wants. By the way, our stack is 4.2 qualified, but there are a couple of hard IP features at that time were not available, which are optional, that's why we market it as 4.1. So there are only a couple of things which not supported as 4.2. Let's look at the block diagram for the G1D. What it is a RS78 core, which is our lowest power core for Renesas. And it works at 32 megahertz, and it's pretty efficient. It's 1.4 almost DMIPS per megahertz. And you get three different memory choices for this particular device, 128, 192, or 256, your choice which you pick. The transmit receive currents are the major differentiation. So the transmit current is 4.3 milliamps, and the receive is 3.5 milliamps. And that's one of the lowest.
That's 0 dBm?
0 dBm at 3 volts, yes. Sorry, go ahead.
What's your sensitivity and reception?
Sensitivity is 90 around 90 something. 86 to 90? Yeah, it's 90. Yeah, 90 something, yes, 90. And you can see the stop and the sleep currents. So you are 270 nanoamps, I think, is the lowest current. And then you got 2.3 microamps for the sleep mode. And it's got some decent analog and precision temp sensor, voltage reference on board. Good amount of timers and serial interfaces are included on this chip. And our power management for RS78 is pretty unique because it's got halt, snooze, stop, and a deep sleep mode, so it lets you do a variety of things. Temperature, this is minus 40 to 85, so industrial. So what you're getting is the RS78 core with the state-of-the-art BLE radio. So, and this chart here should basically summarize why power is the differentiator and what it takes. So this is a typical cycle for a normal Bluetooth operation. Every 1 second you wake up and you transmit a packet or two, right? One packet. In that case, our average consumption is 10 microamps. Of course, for each application it'll be different, but this is sort of a typical rough idea. It gives you what type of consumption you're going to have. Let's go to the second differentiating factor, which is low BOM cost. So we have done it. We have integrated a lot of functions into the IC, which basically gives you, which saves you cost and not much external components to use. On the right side is a simplified diagram showing what all we have integrated above and normal, what others may not have integrated. The balloon is integrated, so all you need to do is a single-ended PCB antenna or a chip antenna. You don't need any matching network. The DC to DC for the RF is integrated, and the low-speed clock for the Bluetooth communication is integrated. So you don't need RTC if you don't want the precision on the serial side, interface side. So those three things are integrated. This is the typical layout, which is a real case example. Just shows you can get away with some passives and one crystal, an antenna, and that's your full Bluetooth BLE plus MCU implementation. There's a very cool feature we have added. It's called the adaptable RF technology, which helps you improve the power efficiency. What it does, based on distance, it's going to adjust your power numbers, transmit receive numbers. So, of course, depends on the application, but if you're close enough, it's going to reduce the power transmit receive currents. If it's further away, it's going to pump them up. And if you're not comfortable, it doesn't work very reliably for you or a particular application, you can go to the fixed mode available. You can just shut it off.
Is that in the standard?
No, this is just Renesas. No. Okay, let's look at system use cases. So this is a very standard question most people will have, how they're going to implement this function into their product. So we support both the cases, like there's a modem, we call it modem configuration and the embedded configuration. In the modem, our device is just a radio, and all the processing happens on the application MCU. So for application like a watch or where you need higher end processing, that would be the use case. For something like a locator tile or something, you can run almost everything on our device, and that would be the embedded application case. So we support both the cases. We also have support for all the standard serial interfaces, which you can see on this slide. SPI, I2C, and UI. So you're getting flexibility. So you don't get stuck with, suppose some particular serial interface tied up on the MCU, the other side. You can move on to a different one. Okay, the stack. So the stack comes free with the device, and it's, as I said, 4.2 certified with the Bluetooth SIG, and again supports two configurations, as I mentioned, the modem configuration and the embedded configuration. On the left side, you got the modem configuration where the core UART stack runs on our device, and then we provide a RBLE host with an API interface where you write your profile or the application. So that would be the modem case. And in the embedded case, everything runs on our device. You just work at the API layer, and you write your profiles or application. We also have a little scheduler in there. It's called RWKE, Renesas Wireless Kernel Extension, but it's a little bit scheduler because it's not a big amount of horsepower in the RS-78, so, but it's good enough for basic small applications. These are the options when you open up the header file for the stack. I just wanted to show it's flexible. You can pick and choose what you want from the stack when you're loading it up.
What's the onboard sleep clock accuracy? Is that 500 BPM?
There's adjustable, I think it's the calibration what it does. The 0 to 500 ppm, right, the setting?
Is that, say you put a 50 BPM clock outside and you tell it this is a 50 BPM clock, is that what that's saying? And then I would assume the high end would be the internal accuracy. Is that correct?
Right. So if it's running the internal low speed oscillator, then the accuracy will be slightly low. Or you have the
What
option to
do you know what
connect
it is?
It's going to be under 500 ppm. So it basically meets the BLE requirements, the 16 kilohertz requirements that BLE has under 500 ppm. So it meets this.
I think that this part is consumer part, not automotive part.
Correct.
Yes. From the reliability, yes. From the development environment, we have EV kit, which is certified for 5 different regions in the world, and you got the GUI to go with it. So you, over a UART or a USB connection, you can use the combination to evaluate the device. We also have an Android and iOS app, so if you want the other side to be on a tablet or mobile, you can evaluate the different profiles. From the IDE point of view, we support E2 Studio and IR systems. And we have a little applet, which is our own code generator for generating drivers and the configuration setup for this device. Comes with, and even debugger is what we use for debugging purposes. So that's your sort of evaluation / development environment. Now, if you're looking for more than that, you just don't want to evaluate into basic, but you want to do like product level type of development. So we're going to have a solution kit, which is right now being developed. It will be ready by end of year. What the solution kit will let you do is exercise this device in the embedded mode and the modem mode. So on the left side, I have the RS-78 target board, which is our device, the green one on the top left. And the activity module, the picture is on the right bottom. What it has is lots of sensors: temperature, humidity, pressure, 9-axis motion sensor, and a couple more sensors, wireless charging, fuel gauge on it. So you put that target board on there, and you write your application, and we have an app to go with it. So that becomes your embedded mode, what do you call it, demonstration or your trial. Of course, you can write your own stuff on it. And then on the right side is the modem mode, where you use the S3, which is one of the Synergy devices, which was just recently introduced. That's the target board there on the top right. And then you use the PMOD module, which comes with it. to make our device a radio modem configuration. And then you can play around with it. Yes?
Is that available now in Synergy or?
This kit, so the question is this solution kit available as part of the Synergy, right?
Yeah.
So this kit's not part of Synergy. This kit is part of the RL78 solution kit.
Okay.
So it will be a RL78 solution kit.
So you got Synergy on the right.
That's just a snapshot for the application.
Okay.
For the app which comes, the iOS and Android apps which come with this particular kit, as part of that. But as part of the Synergy, some of the SKs and DKs on S7, our device is on there, on the boards now.
So to expand on that, the modem mode that is shown there, the main MCU is the Synergy S3 device. And the BLE MCU is a co-processor to that device. So the picture on the right, the modem mode is a 2-chip solution, and the picture on the left is a single-chip solution. So if you have a simpler application where you're just sensing like maybe 1 or 2 sensors, you can use the RL78 to do both your MCU as well as the radio. And on the right, if you need a more powerful MCU, we have the porting done to Synergy. But we have a demo at our booth, but this will be available soon in like a couple months time.
Okay. And we're gonna make a little PMOD adapter to plug into the Synergy port. So we'll have that in the fourth quarter.
And the kit also has a USB dongle. So if you want to plug it into a PC and do some development, then you can use the USB dongle. So it's a very versatile kit. Will let you do different things.
Do you have the LIN communication stack supported on your platform? Is it available as a software package?
So the question is, do we have LIN supported on this platform? So on this particular Bluetooth device or on the RL78 platform?
On the RL78.
We have a device with the LIN interface, yes. There's a family, this is a big family, the RL78, right? It's a 8-bit, it's a 16-bit MCU portfolio. So we have devices which have LIN and CAN and different interfaces, yes. But I'm not very clear if the question was.
On the
This
integrated
specific device doesn't have LIN.
Yeah.
But the RL78 is a family with more than 800 parts in it. And there are families which support CAN and LIN.
Yeah.
In the
And automotive grade too.
I mean, on the BLE chip, you said you have the interface support is UART.
SPI and I2C.
So the physical interface is the same UART, but do you have the LIN communication stack implemented?
I see. No, we don't. But if there's a use case like that, and if that's possible, we can look into that. But no, we don't today. So you want to use UART as the base layer, physical layer, and you want to do LIN on it. No, we've not done something like that because never had a request like that. But if you have a specific need, we can look into that. No, not G1D. Now, around 50 to 60% of customers usually look for a module, and rest of them want IC. So as far as modules go, today we have a reference design we can share with the customers if they want to use that and go to production with that. And the size is, compared to a penny, you can see that it's pretty good size of the module, and it's certified. We will be also engaging with third-party vendors to commercialize modules for us. Today we have Gainspan, which has in the process of commercializing, and they have a booth in the exhibit area where you can see the actual samples for the module. So certified modules also will be available as one of the choices.
Plus, we're the nicest vendor.
You have to give something to them. Your question, sir?
You're marketing RL78 for the Bluetooth Smart only, not for Smart Ready?
So the question is, are we marketing RS78 on G1D only for Bluetooth Smart? So this is only a Bluetooth Smart device. It's not a classic device. It's not a dual mode device. It only supports Bluetooth Smart. Now, to help out, if you're going to do some development using Bluetooth, and since we had some information from Bluetooth SIG, I wanted to put this slide up, which may help a lot of these people out. So Bluetooth SIG has taken initiative to give some tools and build some stuff up now, so to enable the community and make life easier. So on the left, you have a profile tuning suite, which if you use with the PTS radio, that radio is available for $99. It becomes a virtual sniffer and also can be one other side of your development environment. It has built-in stuff for profile testing and related information. So you don't have to spend money on an expensive sniffer or some tuning suite. So that's a cheaper way of tuning your profiles. And then on the right side is the Bluetooth Developer Studio, which is a graphical-based coding tool. So you can just plug and place those characteristic services and it'll automatically assign UUIDs and handles and make a custom profile for you. So what we do is we have a plugin behind there which will generate the code for our IC. So that's a pretty good, it's released now. October 15th it's going to be released. So that's, I think, a pretty good tool if you're going to do Bluetooth development. Makes life much easier. You don't have to go and figure out all the line codes. Okay, so in summary, what we covered, we went over the IoT definition and market size, role of Bluetooth in the IoT, Bluetooth Classic versus Bluetooth Low Energy, selecting a Bluetooth solution, and went over Renesas RL78 G1D features, hardware and software tools for supporting that. Conclusion and tying it back with the opening summary. So I think Bluetooth is going to be the leading connectivity standard in the WPAN space, and it's going to play a large role in getting devices connected in IoT, especially with the features being added on. If you want to connect your device or product to the IoT, I would suggest leverage G1D's low power and its ease of implementation. At the end of it all, I hope you all are ready to leverage Bluetooth capability for your products. And before we get into question and answers, I would like to mention the demos we have using our device so you can get a feel of what the device can do. The table numbers are mentioned here. We got a headless activity monitor, there's a pulse ox demo, there's a smart door lock, and a LifeLog IoT device demo, which goes all the way to the cloud and comes back. That's the setup. The smart lock is very cool. It uses Cap Touch and Bluetooth connectivity to open up a lock. And then there's an activity monitor, uses Bluetooth for connectivity, and there's a pulse ox board. So those are some of the Bluetooth demos we have. Yes, sir.
Okay, question, two pieces.
Yes.
If I design your part in, can I use the Bluetooth logo on my product? Does it pass down?
No. So this is a component level. So what we get certified is the SIG, right? This is the stack. We certify the stack. We have a QDID for the stack. And then radio certification completely different, right? When you make your product, you have to register with the Bluetooth SIG. It's $7,500, and they give you a QDID. That's what gives you the right to use the logo.
So the module that you make,
Yeah, that's for radio certification.
right, do I need to recertify my product if I put it on my board?
No, not the radio. No. That's the whole thing about the module versus IC. Yeah. It's different, yeah. It's your product, you closed it out, you want to put that logo, you registered. It's only $7,500 one-time fee.
So our stack and our device are pre-certified components. So when you submit your system to the Bluetooth SIG for certification, you can give the UUIDs of our certified components to the SIG, which will simplify the certification period.
It's
Can you build a product without the logo, without paying the $7,500?
Yeah, I think who's going to, okay, the question is, yes. The question is, can you build a product?
No. Yeah, that's why I asked.
You can hand it out. Here you go, sir.
The
The question was, can you build a product without the Bluetooth logo? So the answer is, it's your choice. They're not going to police you. Bluetooth 6 is not going to come after you to police you, right? But you're not going to have the credibility of not having the logo in the consumer space. Yeah, it's not legal, or it's a right versus wrong thing. It's
So
not.
you're supposed to, even without putting the logo.
It's a right
on the
versus
box.
wrong thing. Yeah,
Okay.
it's your decision. There's no legal ramifications, but. Yeah, you should exactly pay your fees.
For asking that question.
Any other questions? Do we have any other questions?
Yeah, I have three more things to give away.
What's your roadmap for,
For this product?
what's your roadmap for BLE devices moving forward? Not stack.
Yes, for the hardware, right? So what we're going to do, the next generation, which is coming out in 2016, right, the standard, so we're going to use that as the basis for our next devices. And the next devices will be on the Synergy platform, which is the family which was ARM-based, yes. Might have the plans being laid out as we speak, but could be a radio mode device and a higher-end device with dual-core. So that's the way we're leaning. Yes. Yeah. Mm-hmm. Yes. That's the way.
Changing the process technology when we move forward.
Yes. Most probably. Mhm.
Too soon to answer that question.
Just ballpark, when do you think that would be coming out?
Plan is the 2017 by mid-year or something. That's the plan.
There you go, you get the t-shirt. You have
Yeah, he's good. Okay.
one more question.
And if you get time, please fill out the survey on the app. And hopefully we get to see you all in the exhibit hall. There are some nice demos there in the evening. And thank you for your time. Enjoy the rest of the show.